we're going to look at a linear programming question. This question is taken from Jan 2008 CSEC paper, paper 2. Question is extremely long, so we're jumping right into it. All right, so a school buys X balls and Y bats. Right, so X represents the number of balls and Y represents the number of bats. We said the total number of balls and bats is no more than 30. So balls X and suggest plus total number. Bats represents Y represents the number of bats. No more than is less than or equal to 30. So we're bringing in the inequality sign there or symbol 30, right? So when they ask, write an inequality to represent this information. So this here is simply X plus Y less than or equal to 30, right? One time. So they said here, the school budget allows no more than, you see a no more than again, less than or equal to, right? No more than 360 spent. So the total number of bats and balls that you're spending, you cannot exceed $360. So the cost of a ball is 6x, was $6. So the cost of a ball is $6. So the 6 times X means each ball costs $6, and suggest plus the cost of a bat is 24. So we have 24Y because each bat is 24. Y represents the number of bats and each bat costs $24. So write an inequality for this information. So we have 6X plus 24Y less than or equal to 360, right? Usually I tell students, I say if you have an inequality with large numbers, see if you can simplify. So 6 could go into everything here. So if 6 into 6 is 1, so we have 1x. 6 into 24 is 4y less than or equal to 60. Right, so there's an equality right there. Now part B tells us using a scale of 2 cm on the x-axis to represent 10 balls, 2 cm on the y-axis to represent 5 bats. So you have to draw the lines associated with inequalities in 1 and 2. So we're looking at this one and that one. So let's head up the scale one time. Two centimeters on the x-axis to represent 10 balls. Right, balls is just x, right? So 2 cm on the x-axis to represent 10 balls, 2 cm on the y-axis to represent 5 bats. Right, so this represents bats. Y. So we need to deal with these two inequalities. So in order to draw a straight line, we need 2 points. 2 points. Let's deal with x plus y less than or equal to 30. So we have x plus y less than or equal to 30. So when x equals 0, you could use any number. I just like to use 0 because it's the easiest to get 2 points out of this equation. Rather than put less than or equal to 30, we deal with x plus y equals to 30 in order to get a line. And then when we get a line, we'll deal with the inequalities symbol. So when x is 0, y is 30. So we have 0, 30. When y equals to 0, we have 30, 0. You can choose any number, 1, 3, doesn't matter, but 0 is the easiest and fastest number to choose and work out, right? Fast. So we have 0, 30, 30, 0. So when we look at the graph, 0 going up to 30, remember x comes first, y comes second. 0 to 30, that's this point here. And we have 30, 0. 30, 0. Right. So we have those 2 points. We take our ruler and we draw a straight line. Now let's deal with the inequality symbol. So we deal with x plus y less than or equal to 0, less than or equal to 30. Right? So x plus y less than or equal to 30 is everything below this line. Less than. If it was more than, it'll be in everything above the line. Right? So since it's x plus y less than or equal to 30, it's below the line. So we draw some small arrows to indicate such. Right, and you label your graph. X plus y less than or equal to 30. So let's look at the next one. The next one is x plus 4y less than or equal to 60. We're using that one, which is the simplified version for 6x plus 24y is less than or equal to 360. All right, so we're going to get our points. When x equals 0, 0 plus 4y equals 60. That is equal to 15. So this is 0, 15. Right? So when y is equal to 0 now, so we have 60, 0. Right? We have 60, 0. Boom, boom, boom. But so we're going to plot that now. We're going to plot 0, 15, 60, 0. 0, 15 is here. Right? 0 going to 15 is there. And 60, 0 is there. Right? 60, 0. So we need to take a ruler, draw the straight line. X plus 4y less than or equal to 60. Right? Less than or equal to 60 means it's below the blue line, not above. Less than or equal to 60 is below this line. So this is x plus 4y less than or equal to 60. And you represent that by putting your arrows below. All right, put your arrows below. Make sure you label your graph one time. So continuing, because we dealt with part B1, part B2, they said shade the region will satisfy the two inequalities at part A1 and 2. And the inequalities x is more than equal to 0 and y is more than equal to 0. All right. So let's deal with x equals 0 and y equals 0. X equals 0. Right? X equals 0. It's a straight line. going down on 0. This line here is x equals to 0. Right? That's this green line here, x is equal to 0. Right? If you check out my types of graph video, you understand that better. I'm not going to elaborate on that. You can look at that video. Now we are dealing with x is more than or equal to 0. So x being more than or equal to 0 is everything, right? Everything here, more than or equal to 0. So what we do is we take our arrows, we draw small arrows. X is more than or equal to 0. All right, so we have x is more than or equal to 0. So let me just put that here. X is more than or equal to 0. Now we're going to deal with y is more than or equal to 0. A horizontal line going across on 0. Right, let me just right. Y more than or equal to 0. So this line here, this orange line represents y equals 0, right? Because all the y values on that line equals to 0. Check out my types of graph video. You'll get more clarification on that. Y more than or equal to 0 will be everything above, right? More than or equal to 0 is everything above. Nice. So in order to show that, you put your arrows. Right. Y is more than or equal to 0. So continue it. So they said shady region will satisfy the two inequalities. So let's deal with that. Right. So shade the region will satisfy the two inequalities from 1 and 2 part A, and inequalities x is more equal to 0 and y more equal to 0. So the shaded region is we're looking for when all the lines intersect. So all the colors intersect. Here the green is everything out here, but the purple is everything below here. All right. So but the blue is everything here. We can't go beyond the purple, right? So we have the blue here, the purple here, the orange here, and the green here. So inside here represents the shaded region. So we're going to shade that. So right inside here represents the shaded region. And let me deal with this here. Right. That is 0, 15, 0, 15. This here, 0, 0. Really significant here is 30, 0. And here is 20, 10. Very important. We put that one time. All right, so we shade it. Use your graph to write the coordinates of the vertices. So that's what we did just now. 2 marks with us. The coordinates of the vertices there, by the shaded. All right, I'm gonna put a little extra line up here. Nice. And the next one, they said, the balls and batters sold to students, right? The school makes a profit of $1 on each ball and $3 on each bat. So the profit is x plus 3y. So come like this say, 1x plus 3y. So the profit is 1x plus 3y, right? They say use the coordinates of the vertices given in B to determine the profit for each of the combination. And when we do that, then we'll hence state the max profit that may be made. Right. So all right, on each vertices first. So we have 0, 15, 20, 10. So we have 0, 15, 20, 10, 30, 0. Right. Now, I'm not going to write 0, 0. Not going to make sense. All right. So this is x, y, x, y, x, y. Right. So profit is equal to 1x plus 3y, I think. Yep, 1x plus 3y. So that is, for this one is 1 by 0 plus 3 by 15. Right? So 1 by 0 is 0, 3 by 15, 5 3s are 15, 1 3 is 3, and 1 is 4. So this is $45. Now this one here, P is 1x plus 3y, 1 by 20 plus 3 by 10. So that is 20 plus 30, and you will get $50 there. And the profit here is 1 by 30 plus 3 by 0. We have 30 plus 0, 30. So this is part C. This is part C1, and part C2 is here. Part C2 said, hence state the max profit that may be made. So the maximum profit is $50. So here we have all our working, right? And here we have the actual graph. All right, so that's it for linear programming.